Okay, we're going to start our next unit. We're going to start with geometric sequences. A geometric sequence is a sequence in which the ratio between consecutive numbers is constant. And a common ratio is whatever that ratio is between consecutive numbers in a geometric sequence. And if you remember, a ratio is a number that can be written in the form A over B. So these will be in the form of either multiplying by the same number or dividing by the same number. All right, example 1, finding the common ratio. In order to find the common ratio of each sequence, what we do is we have to take one of the numbers. We'll start with 12. We'll put 12 over 3. Okay? When we take 12 over 3, we get 4. So our common ratio is 4. So what that means is each time we are multiplying by 4 to get to our next term. So that's what you have to do. You just have to take one number and put it over its previous number. So for example B, we can do 20 divided by 80. Okay, this will reduce. Both numbers are divisible by 4. If we reduce it by 4, okay, we can get 1/4. Actually, I'm sorry, by 20. If we divide top and bottom by 20, we get 1/4. So we know that what's happening is we're multiplying the next number by 1/4. The other way you can think about it is the next number is found by dividing by 4. So in a geometric sequence, it's either going to be multiplying by the same number or dividing by the same number. If you remember back when we were talking about arithmetic sequences, the difference is in arithmetic sequences, we're adding or subtracting the same number. So this time, we're going to be multiplying or dividing. So let's look at example 2. Example 2 says find the next 3 terms of the sequence. Well, in order to do that, we have to find out what's happening. So we need to find that ratio. So we need to do like we did on the last example. We're going to divide two numbers. We're going to take -6, put it over 2. And what we get when we divide that is we get -3. So that's what our common ratio is -3. So that means we're multiplying by -3 to get each number. So to get the next sequence, get the next number in the sequence, we can multiply -54 by -3. And what you will get is a positive 162. And then we multiply by -3 again to get -486. Multiply it one more time by -3 and we get 1,458. When you have to multiply by a negative number, your sign is going to switch every other time. So that's how you can tell if you're doing it right or not. Now earlier I brought up our arithmetic sequences that we talked about a few months back. And so now we're going to be able to try to figure out if something is an arithmetic sequence or if it's a geometric sequence. In order for something to be a geometric sequence, the ratio for every number has to be the same. So the way to look at that is let's do -5 over -7. That's going to give you a positive 5 over 7. So that's the ratio between these two numbers. Because the ratio we're looking at is between consecutive numbers. So let's try the next set of consecutive numbers. And we get -3 over -5, which gives us 3/5. These ratios are not the same, so it is not a geometric sequence. What is actually happening, though, if you look, what's happening is we're adding 4 each time. And that is the same. If we're adding or subtracting the same number each time, then it's an arithmetic sequence. So this one would be arithmetic. The next one, let's check our ratios and see if we get the same thing each time. So let's do 28 and 56. If we take 28 divided by 56, we're going to get 1/2. Now let's check the next set of consecutive numbers. 14 divided by 28, also 1/2. So this one is going to be a geometric sequence. So that's how you can tell the difference. If you're multiplying or dividing by the same number every time, it's geometric. If you're adding and subtracting the same number each time, it's arithmetic. So that's how you can tell the difference between geometric and arithmetic. Now, we can write a rule or a formula for a geometric sequence. The rule is a to the n, or a of n, I'm sorry, a of n equals a times r to the n minus 1. So let's label what all these things are. Your a is your first term in the sequence. A is always your first term in the sequence. R is whatever that ratio is that you found. And n is the term number, whatever term number you're on. So that's how you write a rule for a geometric sequence. Now we can use these rules to find certain term numbers. So if you look at this next example, it says find the first, fifth, and 10th terms of the sequence that has a rule a of n equals 5 times negative 2 to the n minus 1. So here's how we work that problem. Let's write the function here. A of n, remember this is also a function, 5 negative 2 to the n minus 1. So what we're going to do is we're going to take turns plugging in 1 for first term, 5 for the fifth term, 10 for the 10th term. So if we plug in a 1 for n, we're going to get a of 1 equals 5 times negative 2 to the 1 minus 1 power. So this is where the n is where you plug in that 1 or 5 or 10. So let's go ahead and simplify this. We get a of 1 equals 5, and then we have negative 2 to the 0 power. Well, we've just learned recently that anything to the 0 power is 1. So a of 1 is going to be 5 times 1, which is going to be 5. So the first term of the sequence is 5, which in our formula we could have figured that out because this number right here is always our first term of the sequence. Now we can plug in a 5. Okay, so what we get is we get 5, and then negative 2 to the 4th power. All right, if we take negative 2 to the 4th power, you're going to get 16. So it's 5 times 16, which is 80. So the 5th term of the sequence is 80. All right, now let's find the 10th term. We're going to plug a 10 in for n. All right, so we get 5 times negative 2 to the 9th power. Okay, negative 2 to the 9th power. You might have to put that right into your calculator. You will get negative 512. So we get 5 times negative 512. So our 10th term is negative 2,560. So as you can see, the numbers get pretty big pretty fast in a geometric sequence. So anytime you're having to multiply by the same number each time, sometimes those can get really, really big. Or if you're dividing by the same number each time, they can get really, really small. But that's how you find any term number. We could have plugged in anything in for n. We could have plugged in a 6 if we wanted the 6th term. So you just have to replace n with whatever term number it is that you're looking for. All right, example 5. You drop a basketball from a height of 2 meters. Each curved path has 56% of the height of the previous path. Using the 8 in centimeters, write a rule for this sequence. What height will the basketball reach at the top of the 4th path when n equals 4? Round to the nearest tenth of a centimeter. All right, so what's happening here is we have a basketball that gets dropped, okay? And then with each pass, it gets a little bit smaller in height, okay? And each time, it's 56% the height of the previous path, all right? So what we do is we start with our starting height is 2 meters because we drop it from 2 meters. So this first number in the sequence is a 2. We want to find out what the height is in each of these other numbers. So now our regular rule for a geometric sequence is a of n equals a times r to the n minus 1. R is our rate. They give us a rate of 56% each time. So we can put that in for rate. Now we know our first term is 2 because it starts from 2 meters. So we have 2 times, all right, 56%. To write that in a rate, we can write it a couple ways. We can write it 56 over 100, or we can write it as 0.56. We'll go ahead and write it as 0.56 to the n minus 1. So this right here is our formula. All right, and then it says, what will the height of the basketball reach at the top of the 4th path when n equals 4? So now we're going to plug 4 in for n. So we get a of 4 equals 2 times 0.56 to the 8. Sorry, not the 8. We're looking for the 4th path. 4 minus 1. So we get a to the 4 equals 2 times 0.56 to the 3rd power. We put this into our calculators. Okay, we're going to get the 4th pass. The height is going to equal 0.35, and then we're talking in meters. So 0.35 meters. It starts off at 2 meters and it keeps going until it gets down to 0.35 of a meter, which is going to be 35 centimeters. So that's how you use geometric sequences. Thank you for listening.